I still remember my first receiver was an HRO, national HRO. Got it from junk market, modified, not modified, uh, repaired and used. That time I was looking for, uh, trying to think about a cost-effective transceiver. I have already told this story several times. During that period, I was also had joined the Himalayan car rally expeditions, which was sponsored by Farsi that time. Not sponsored exactly. The Ham movement was sponsored by Farsi that time, controlled by Farsi that time. And during one of those rallies, I came across the wonderful Atlas 210 X-ray. That was a first solid state rig built in USA. That was the first solid state rig 100 water. I was fortunate enough to get that rig into as the rig for my portable operation during that rally. Unfortunately, there was a problem in that rig. When it was given to me, they said it doesn't have it has a very, very low audio. You can't listen to anything. You have to carefully listen. I mean, can I do something with that? Okay, I'll try. So initially, when I took that, I just bought an ampli speaker from the market. I connected it to its earphone jack, and using that as a audio volume to listen to the stations. So I thought, let me see what exactly has gone wrong. So I opened up that set. Of course, I think it was a VU2IG Jimmy Mistri's set, because he was very active that time. So I opened up, I saw the problem was very, very minor. And when I saw the whole circuit, I had the manual also of that thing. And I was really wonderstruck with the simplest possible methods and systems. They had made this solid state transceiver. So that gave me encouragement that something on this, with the available parts here, we can probably, why we can't make it. So I took up that idea. The crystal filter what Atlas has used was 5 megahertz. 5 megahertz band. It's meant for 5 megahertz. But those were not available that time. Bell crystal filters were available for 9 megahertz. They were available for rupees 500 or something that time. I'm talking about 84. So I thought, let me plan my transceiver on using Bell megahertz, this crystal. So with that, I started making that thing, made available parts again. Simple germanium transistors were available there. Few of the those time considered tried, for example, 23866 was one of the transistor. It was available then. CA3028A was also available as a complementary. They were the initial stages of ICs, rather it was a round thing. So I said, let me try something. So I made a first transceiver and on Vera boards like this. The first different stages, worked on it, and I could find that it works wonderfully well. It worked wonderfully well. So we had a club there in Gwalior Amateur Club. The president at the time was VU2ASH, Mr. Kulkarni. He is no more now. And the secretary was Mr. Aloni, VU2KH. He's also no more now. So, why not do something? And during this period, I was lucky to have a visit of Saad Ali to Gwalior Amateur Club during that time. He also saw this project of mine, and He saw this is something wonderful, Ashok, you are doing. Why don't you do it for Farsi? Definitely, I can try, but I told him I'm working as an engineer in a factory. I don't have much time, but still I'll try. So then I said, let me make it in a little professional way. So I made the first PCB, learned how to make the PCB first, and made the first PCB with nail paint. Didn't know the photo transfer or toner transfer method at that time. So made the lines and this thing with nail paint using my wife's nail paint and making the lines. Made the PCB that thing and then made the first set. Of course, few torides and parts which were required. I requested him if he can arrange them for me. And yes, he did arrange. So the first prototype was made and worked very nicely, putting out 10 watt. There were some drawbacks, of course. Initially, I was using a VFO, a variable frequency oscillator. Now, the combination with 5 megahertz for different bands is something different. The VFO frequency is substantially low. But when you have to try on 9 megahertz with the required things, the VFO becomes a little higher. The stability problem was quite substantially high. Had to do a lot of experiment for VFO stability. And then made the first VFO based transceiver for 4 bands. The view is there before you. It had a USB, LSB selections, main VFO, the band switch. The band switch was another problem. It requires switching of bands at the VFO level, at first RX input BPF level, at transmitter input BPF level, and the LPF. So it had to have 4 stages. And for a length of, say, quite substantial, you can see it, the length of these. It starts from here, from the front panel goes right here. So this band switch was a problem again. Yeah, well, being a mechanical engineer solved my problem. I got them fabricated on a local workshop with my friend, got them welded, everything, made experiments. The side things were made from bicycle spokes. Doing that combination, yeah, that band switch worked very nicely. That problem is solved. And the first transceiver was made that time with VFO. But stability was problem. Little low band, it was quite stable. It used to take normally about 15 to 20 to 30 minutes to stabilize. So that otherwise it used to drift this way, used. It does require a lot of closed cavity, and made a special cabinet, metal cabinet for that. And then later on, it had a simple drum and light dial type indication for frequency. So did a little modification there, stabilized it. The FETs were started. I mean, they were also, we could BFW10 and BFW11, they were available at that time. So using them, first off, I had made the VFO with a discrete transistors, but then I went down to FETs and the stability could be improved a lot. But the display was again something that was just a dial. So we concentrated on making a digital display. Now the picture which Anil has shown, it has got a digital display. Now, this digital display, again, it was designed by several combinations, and it could show the last 4 digits of the selected frequency. That's what combination, again, we had to go in and study. The digital display, you can see it, there are last 4 digits. I mean, when you change the band, if it is on 7, it will show the last 4 digits, 7, then 3 digits further, up to 100 hertz level or something like that. But it did have, we had a little problem with the noise level. So then again, we made a complete box containing, and then we could get a little lower noise level. Then we added a S meter also to it, to show the modification were done to show the receiver uh, signal strength and the transmitted power signal strength. In fact, I wanted to make this, you showed the only the transmitted power signal strength, not forward reverse. Later on, I had added up SWR bridge also to that, but that was done afterward. So with this only, this combination, this was just a switch which showed operating power and RxS. This meter could show while receiving, it used to show the S meter, and when we want to specifically see for power, you switch it to this, and you can see what is the RF output power you're getting. The getting of jacks, the jacks were also different. So whatever available in market, so this type of jack for key input, the key input, state key input, used. This is for earphone jack. This is LSB and USB selection of filter, because bell filter used to come with two crystals for a USB and LSB. And with the tuning, of course, the circuit was made so I can tune the crystal up and down, both of them, to exactly match the required clarity of the signal. Now, this was the main switch, again, a small band switch, which is off as SSB and CW. In CW mode, the same circuit, the balance modulator is fed with a DC voltage. So this DC voltage was selected from here. When I put it to CW, the balance motor is fed to and the amount of DC voltage fed to the balance modulator to leak the carrier was again controlled by this single mic control and CW control again. It's something similar to Atlas. It worked. Then PTT, of course, this is mic input. This was the AF gain, was using LM380, which was available that time. It gave sufficient output. So this was the AF gain. Another RF gain, the first mixer, the first transistor was 3866, the mixer. And it could work as a RF gain. So this was selected. Later on, I added a small capacitor initially. Then I used a varactor diode to have a little RIT effect while receiving. Receiving only, the transmitting becomes fixed. So this was added later on. The whole thing was motor box with partitions inside. There's a partition inside. You can see here. This is one partition here, and the filters, etc. The input filter, mic gain, input filter, TX filter were put up here inside. Now I changed the location, and the LPF was here and the PA was here, and there was another cover on this side, and this could make the whole setup. So I'm presently, as I said, with this set, I'm doing the modification. So I'm changing the PA also, putting out a little heat sink and all that. That time I had used for PA, I could get hold of good PA transistor, SC1307. Each transistor rated for 25 watts. I was using them in parallel. And then, but I derated them intentionally to put out 10 watts. So giving sufficient margin for the final transistors, so that if someone operates, or if a newcomer operates them without an aerial or even shorted aerial, the finals will not go. So that was the basic idea. So choose a little higher value output transistors, SC1307. That's what I was using. And then the that thing, it worked very nicely. Sadali requested me to make 5 sets of this. I told him I'm working. My work time is right from 8 o'clock in the morning to at least 8:39. After that, whatever time I can make, I will make 5 sets for you. So the whole club, Gwalior Amateur Club, came across this. All members joined us. I made the nail painted PCBs which I had made. I gave them template to one of my colleagues, Mr. Arun Karkare. He got them professionally made from some source with silver plating and all that. But I said, keep the tracks, don't modify the tracks, keep the tracks as they are. Because accordingly, I have laid down the circuit. I first laid down the circuit on a cross graph with the tracks and actual size of the. I didn't have that time, this all PCB making softwares. So I was using a graph paper, cross graph paper with a 1 mm by 1 mm. And I used to put actual component size there and then make the track, and the same transferred by carbon paper on a PCB, and then the solid tracks are painted by nail bend. Rest open. Etching, of course, I could do. So I gave this to I got a set, 5 sets, 5 or 6 sets or 10 sets, something like that. They're made for the PCBs. And then we started assembling those. Of course, Sadali was great help during this, because this is Farsi had sponsored that you make these 5 sets first. And okay, so toroids, even all this thing. Modification necessary, of course, we took at our end, making the band switch, making the cabinet. The front portion was made from acrylic sheet. I got it printed, layout, drawing, etc. Paperwork was done by Alodi sir. Technically, I used to work, right, coming after from the factory, taking my lunch, and then at 10 o'clock, I used to sit on my work table, and up to 2 o'clock or 3 o'clock, I used to complete those sets. So those 5 sets were completed. And during this period, the Hyderabad Hamfest came in. So I had taken that one completed set, my set there as a demonstration. And during that, I had also made one 2-meter transceiver using 8 megahertz crystal and jumping it to 144 and a suitable receiver, and housed in a small, again, aluminum standard box. These 2 projects we had taken there at Hamfest. The 2-meter transceiver was entered in my friend Old Man Jayu. No more, his rest his soul. And the transceiver was entered in my name, and both of these equipment got first prize that time for the Hambrew in Hyderabad convention. Anyway, during this period, several hands we came across to me. I mean, knew, and I was doing their test on the air also. So they said, why not? We want to have one. So I asked Sadali that I have made this for you. Now, what do you want? So they are buying. They want to buy it. Well, okay, they want to buy it. Fine enough. So I think many 3 or 4 transceivers had been given to different boys. Few of them are still operating. That whole thing was maintained by Aloni Sahib and Jayu and all that. And that was quite successful. That later on, Sadali was there. He said, why not take production of this one? Well, I can't do that. At least I said my inability, because I'm already working. I have to support my family. I can't just leave it all that right now. And not difficult. So I said, for production, I will not be able to. You can find a suitable portion. I have got everything available. It was tried further, but I think it was not very successful later on. Unfortunately, Sadali also became ex-silent key during that. So the project was just left at that point. And in the meanwhile, several new things had come up. Quite development. Farhan had brought the PITX. So it was going on. So just kept it. But few of those sets, during those 5 sets which were made that time, they are still working with boys in India. I'm happy that at least whatever efforts I did during that could give some happiness to those boys. Well, that is the short story of it. Now, I had one experimental set with me, so I am trying to upgrade it to the latest conditions. Let's see what happens. Thank you very much.
Thank you, Kaka.